Hey there, data enthusiasts. Welcome back to our channel. Today, we're diving into a pivotal concept in the world of statistics and machine learning, the ROC curve and AUC, two powerful tools that help us evaluate the performance of classification models. Whether you're a seasoned data scientist or just getting started, understanding these concepts will empower your analytical skills. So, let's get going. But first, have you ever wondered how we can visually assess the performance of our models? Or how we can compare different models to see which one performs better? That's where the ROC curve and AUC come into play. Let's break it down. To understand the ROC curve and AUC, we need to start with a few key definitions. So, what is the ROC curve? ROC stands for Receiver Operating Characteristic. It's a graphical plot that illustrates the diagnostic ability of a binary classifier system as its discrimination threshold is varied. Imagine you're developing a model to predict whether an email is spam or not. The model outputs a probability score between 0 and 1 for each email. If you set a threshold, let's say 0.5, any email with a score higher than this is classified as spam, and anything below is classified as not spam. Now, this threshold can be adjusted. When you change it, you'll get different results. This is where the ROC curve shines. It plots two parameters, true positive rate. This is also known as sensitivity or recall. It measures the proportion of actual positives that are correctly identified by the model. Mathematically, it's calculated as TPR equals TPO, where TP is true positives and FN is false negatives. False positive rate, this measures the proportion of actual negatives that are incorrectly identified as positive. It's calculated as FPR equals FP, where FP is false positives and TN is true negatives. So, the ROC curve is essentially the plot of TPR against FPR at various threshold settings. The curve typically starts at the point, moving towards as we increase the threshold. The ideal point on the ROC curve is the top left corner, where we have a TPR of 1 and an FPR of 0. Here's an example. Imagine we have two models predicting whether a patient has a disease. Model A has a ROC curve that hugs the top left corner, while Model B's curve is lower and closer to the diagonal line. This diagonal line represents a random classifier, essentially guessing. Clearly, Model A is performing better. Now, the area under the curve, or AUC, is a single scalar value that summarizes the performance of the model across all thresholds. AUC ranges from 0 to 1. An AUC of 0.5 signifies no discrimination ability, similar to random guessing. An AUC of 1 indicates perfect classification. So, the higher the AUC, the better the model is at distinguishing between the positive and negative classes. For instance, if Model A has an AUC of 0.9 and Model B has an AUC of 0.7, Model A is more reliable for making predictions. Let's look at a practical scenario. Suppose you're working with a data set of loan applicants to predict whether they will default on their loans. After building two models, you generate their ROC curves and calculate the AUC values. Model X has an AUC of 0.85, Model Y has an AUC of 0.72. From this data, you can confidently say that Model X is superior in predicting loan defaults compared to Model Y. This insight can help financial institutions make better lending decisions and ultimately reduce risk. Remember, though, while the ROC curve and AUC are powerful tools, they are not without limitations. They do not account for class imbalance, which can be crucial in many datasets. Therefore, it's always best to use these metrics alongside others, like precision, recall, and F1 score, to get a well-rounded view of your model's performance. So, to wrap things up, the ROC curve and AUC are essential tools for evaluating the performance of classification models. The ROC curve helps visualize how well a model distinguishes between classes, while the AUC provides a single metric to compare different models efficiently. Understanding these concepts not only bolsters your analytical skills but also enhances your decision-making process in real-world applications. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell so you won't miss our future content. And let us know in the comments, what classification problems are you working on? We'd love to hear from you. Until next time, keep exploring the fascinating world of data.